In residential energy systems, most households rely on centralized electrical grids. This structure involves energy generation at distant facilities and distribution through a network of transmission lines. Users interact with this system passively, receiving electricity on demand and being billed based on consumption. Alternative energy approaches exist, including solar panels, wind turbines, and fuel-powered generators. These systems vary in cost, installation complexity, and environmental dependency. Some require professional installation, while others depend on weather conditions or continuous fuel input. Within this landscape, there is also a category of small-scale, user-assembled energy devices. These systems are typically introduced through instructional materials and rely on mechanical or physical principles to generate or store energy locally. The Kinetic Power System is a digital instructional product. It provides a structured guide for assembling a small-scale energy device using commonly available materials. The product consists of a downloadable or online access manual. It includes diagrams, component lists, and step-by-step instructions. The guide outlines how to construct a device based on a flywheel mechanism, a form of mechanical energy storage. The system described in the guide uses rotational motion to store and release energy. The flywheel component acts as a central element, supported by additional parts such as gears, chains, and a structural frame. The product does not include physical components. Instead, it provides the information required for users to source materials independently and assemble the system themselves. The usage process begins with accessing the digital guide. Users review the documentation to understand the structure and requirements of the system. Next, materials are acquired. These may include mechanical parts such as a flywheel, connectors, mounting surfaces, and basic hardware. The guide specifies dimensions and configurations for each component. Assembly follows a sequential process. Users construct the frame, install the rotating components, and connect mechanical elements according to the provided schematics. The system is then integrated with a power interface, depending on the instructions. The interaction is hands-on. It requires physical assembly, alignment of parts, and adherence to the outlined steps. The time required for completion is presented as a few hours, depending on user familiarity with tools and materials. Once assembled, the device operates through motion-based energy principles. The guide may also include instructions for maintenance and optional modifications. This type of product aligns with individuals interested in do-it-yourself projects involving mechanical systems. It may appeal to users who prefer assembling devices independently rather than purchasing pre-built systems. It also aligns with those exploring alternative approaches to small-scale energy generation or storage. The level of involvement suggests suitability for users comfortable with basic tools and procedural instructions. Because the product is informational, its usability depends on the user's ability to interpret diagrams and execute assembly steps. It does not function as an automated or plug-and-play system. Compared to conventional energy solutions, this product operates in a different category. It is not a commercial energy installation, nor a certified utility system. Instead, it is an instructional framework for building a device based on mechanical energy concepts. Unlike solar or wind systems, it does not rely on environmental inputs such as sunlight or wind. Unlike fuel generators, it does not center around combustion-based energy production. Its primary distinction lies in its format. Rather than delivering hardware, it delivers instructions. The outcome depends on user execution, material selection, and assembly accuracy. In the broader context, it fits within the category of instructional DIY engineering guides. Similar products exist across various domains, where users construct devices based on provided schematics. For those interested in examining the structure and methodology described, the product link is available in the video description.